This is lesson 8.1b, where we're going to be talking about exponential functions and how to write an exponential function when you're given two specific points. And it's important for us to remember that whenever we're dealing with points, that these are x and y values. So this is x comma y, and this is x comma y. They are a specific connection, an ordered pair. And when we talk about writing a function, it's important that we have y equals something with an x in it. So you might go ahead and tell me that 14 equals 7 times 2. That is true. It's a true statement, but it's not a function. A function would be y equals 7 times x, which means I could plug in any x value and get some specific y out. So I could plug in a 2 and get out a 14. So this is a function here where there's the x and the y and all the other variables are filled in. So this is a generic form, but it's not the final specific answer that we're looking for. You saw some of this in our last chapter when we talked about direct and indirect, and today we're going to do the same thing with exponential. Remember that your general exponential form is y equals a times some base raised to the x power. Our goal today is that we're going to actually fill in the values of a and b, so those should be real numbers, and leave x and y as variables. How are we going to do this? Well, the first thing is that you're always going to plug in one of the points, doesn't matter. We're going to go ahead and start with the first point here, and we're going to solve for a. Then we're going to plug in the other point, and we're going to plug in whatever we got for a in the first part, and we're going to solve for b. And then once we have that, it'll be easier to explain step 3 to you when you see it. We're going to use step 1 and 2 together to get step 3. And then at the end, you go ahead and you plug in a and b into your formula here so that they take the place of those two letters, and then you're left with your equation. Let's look at some examples of this together. Write an exponential function that includes the points 2, 4, and 3, 16. So step 1, y equals a times b of x. We're going to insert 4 for y and 2 for x. So 4 equals a times the base squared. Step 1 says that you solve for a. So a is connected to b by multiplication. So in order to undo multiplication, we're going to divide both sides by b squared. Cancel this, so 4 over b squared equals a. That is step 1. Step 2 says to plug the other point into our generic form. So we're going to plug in 3 and 16, so 16 equals a times b to the third. And not only are we plugging in the point, we also need to plug in a. So this guy here is going to plug in as well. So we get 16 equals 4 over b squared times b to the third. Now when we have b to the third, that's the same as saying b over 1. So we're going to treat it like a fraction. And now you have a fraction times a fraction, so you have 16 equals 4b cubed over b squared. We can do some canceling. We can cancel b squared with 2 of the b's here. So we get 16 equals 4b. Divide both sides by 4. We'll get 4 equals b. Now this, yay, this is one of our values. That's the end of step 2. Now that we have the b value, we can take and plug that back into the a value, because look at the a value. It's not really a number. It's an expression, but there's still a b in the bottom, and we don't want that. We want a equals a number. So step 3 is that we're going to take 4 over b squared equals a, and we're going to plug in this value here. So we get 4 over 16 equals a, or 1 over 4 equals a. And this is our second yay. Now we actually do have numbers for both a and b. So step 4 is to come back to our generic form, a times b to the x, and plug in 1/4 for A, 4 for B, and then leave the x and the y alone. So this is our final answer. Y equals 1/4 times 4 to the x. If you get that, then you get the whole point of this lesson. That's it. We're going to look at a couple more examples to see different ways that this plays out, but it's the same steps every time. So second example, first point, second point. Step 1, plug in a point and solve for A. So we're going to plug in 24 and -3. And then we need to solve for A. Again, A is connected by multiplication. So to undo that, we'll divide both sides by B to the -3. So we have 24 over B to the -3 equals A. That's step 1. Step 2, y equals A times B to the x. Plug in the second point. So 12 equals A times B to the -2. We also here need to plug in the A value. So this guy gets plugged in here for A as well. So we get 12 equals 24 over B to the -3 equals B to the -2. And now whenever we have negatives in here, the negatives can be confusing if we leave them as negatives. Remember that, side note here, little side bubble thought, remember that negative exponents like m to the -5th is the same as 1 over m to the +5th. It goes from the numerator to the denominator, but it changes its sign. And if you have 1 over x to the -3, that becomes x to the -3. It comes from the denominator to the numerator, change the sign. So we're going to go ahead and do that here with these b's to keep things simpler. So 12 equals 24 b to the -2 over b -3. Let's swap these. So we get 12 equals 24 over this one, the b to the -2 becomes b to the +2 on the bottom, and b to the -3 becomes b to the +3 on the top. So switching from numerator to denominator, change the signs. Simplify by canceling. So we can cancel b squareds with 2 of these b's. So we get 12 equals 24b. Divide both sides by 24. Cancel this. So we end up getting b equal to 1/2. So there's our first value. That is the end of step 2. Step 3 is to go ahead and put these pieces together. So 24 over b to the -3 equals a. And we're going to slip this guy in. B is 1/2. Again, go ahead and take care of that negative right here. So we're going to have 24 parentheses something to the +3. So 1/2 to the +3rd equals A. And again, that third there, maybe another little thought bubble for us. This is really saying 1/2 times 1/2 times 1/2 is what's happening here. So we're getting 24 times 1/8, which is 3. So that's our second value. That's the end of step 3. So our final answer is y equals 3 times 1/2 to the x. All right, next two examples. Same thing, 0.1, 0.2. This one has a decimal. Y equals a times b to the x. So 18 equals a times b to the squared. Get a by itself, so we'll divide both sides. We get 18 over b squared equals a. That's step 1. Step 2, we're going to put in 60.75 equals, now I'm going to go ahead and slip in my a right here. We know that a is 18 over b squared. And then we're going to have b to the 5th power. So the 5 and the 60.75 is the point. This here is my A value that I just slipped in. So we get 60.75 equals 18. Cancel some of these b's. It's going to cancel 2 of them. It's going to leave us with b to the third. Divide both sides by 18. So 60.75 divided by 18 is 3.375 equals b to the third. Now we have to get rid of that third, so we're going to go ahead and take a cubed root of both sides. So cubed root undoes the third. Cubed root, I'm going to have to use my calculator here. Remember, you can go to Math as your Math button, and then if you scroll down your Math button, it's number 4 has the cubed root that you'll need. But the cubed root of 3.375 is 1.5. And now let's go ahead and put that back into this piece. So 18 over b squared equals a. We said b is 1.5, and 1.5 squared is 2.25, so 18 over 2.25 equals a, which gives us 8 for a. So our final answer, y equals 8 times 1.5 to the x. So again, the part you want to make sure you remember for that one is this math key here is how you're going to get that cubed root that we ended up using. And our last example. Y equals a times b to the x. Plug in the 2, plug in the 0. So 2 equals a times b to the 0. Now because we remember our exponent rules, again, thought bubble, remember that anything to the 0th power is always 1. Doesn't matter what it is. So when you see b, even though we don't know what b is worth, to the 0th power we know that that's the same as a 1 right here. So we will say 2 equals a times 1, which is the same as a equals 2. So we actually got our a value a lot sooner than we're used to getting it, which is totally fine. We're not complaining. Let's do our next point. Y equals a times b to the x when we plug in 6 and 1. So equals a times b. Again, anything to the first power is always itself. So this is 6 equals a times b. That 1 just goes away. Let's go ahead and substitute the a value that we know. We know that a is 2. So we have 6 equals 2 times b. Divide both sides by 2. We get that b equals 3. So since we already have the two pieces, a and b, we don't need to do step 3. We already have them. We're just going to move straight to the end and say a equals 2 times 3 to the x. And that's it.